Okay, I think we're live. Welcome to part 2 of the Caddy reverse proxy refactor. We are going to be expanding Caddy's reverse proxy functionality by adding serve SRV upstreams. We kind of have support for it now. If you saw part 1, we kind of talk about that and the limitations there. And so this is part of an ongoing project from a company that is requesting this feature, and so I'm implementing it here, and I'm knocking out a few other open issues while I'm at it. So let's dive in. Thank you to all who sponsor Caddy. If your company is using Caddy, it would be awesome if you could also sponsor its development, because yeah, I do this full time. So what we have here is the reverse proxy handler, and this is just to catch you up from part 1. We currently, the list of upstreams is hard-coded. You just specify which backends you have. But what we implemented in part 1 was a dynamic upstreams module, basically. Or we didn't implement the actual module, but we added support for using that module. So instead of specifying upstreams in your JSON config, or we can add Caddy file support later, you specify dynamic upstreams. And these can be implemented by any module that supports, that has a method here that implements this interface upstream source. So we decided that upstream source modules basically just return a list of upstreams to use to handle a request. They'll be load balanced and health checked, but there are a few caveats. This has to be a very fast function because it's right in it happens for every request and possibly multiple times, because I'll show you that in a second. And so I think, yeah, because this function may be called during each retry as well, multiple times per request. So it needs to be really fast. And also the returned slice needs to be stable. So the list of upstreams needs to be somewhat consistent. Otherwise, it's going to mess up your load balancing. But for the most part, like, yeah, just try and keep things kind of in the same order each time. If it's worst case scenario, it's a different upstream or different list of upstreams for every request and every retry during every request, it's going to be weird, possibly. So you'll see that we call this, when we're serving an HTTP request, we get the request ready, and then we begin the proxy loop. This is the retry loop. And the first thing we do within the loop, we decided to move this, I think in part 1, this code here was actually right before the loop. We would get a list of upstreams, but we had a request come in right after I streamed that also, like, it benefited from having this inside the loop. So let me see if I can remember. The goal was to be able to receive requests, and then while the backends are down, Caddy will hold on to them and retry, and that's how Caddy currently works. But the goal was to be able to add an upstream through like a special API endpoint, which we would need to add. But if we could add an upstream without having to do a whole config reload, then those requests that are blocked could be allowed through to the new upstream without dropping the request. So that's a really cool idea, but it does require that between retries we get the latest list of upstreams. And anyway, we'll deal with that feature a little later, but the basic idea is that we start with the static list of upstreams, and if a dynamic upstreams module is set, then we actually will use that instead. So we'll call get upstreams, pass it the request, it will return a list of upstreams, and then we use that. And that's kind of all there is to it. The load balancer will then choose an upstream, and the reverse proxy does the rest of its stuff. So the piece that's missing here is that we have no dynamic upstream modules as of yet. We have nothing that implements this interface upstream source. And we want to be able to do that so that we can implement proper like SRV load balancing. Also, hello to everyone who's watching, all 2 of you. Glad to have you here. You can use the chat. It's a little delayed, but I'll see it eventually and try and answer. Just for refresher, an upstream is a struct that has a host. These hosts contain global state. They're shared across all handlers, whereas upstream is specific to a particular reverse proxy config. We talked about the nuances there in the first part. Upstreams have a dial address, and this is our current lookup SRV support, which is a little limiting. Doesn't really work well with load balancing and health checks. And then just some state that we keep track of. And yeah, this is our current SRV support. It just uses the first one and acts as one upstream instead of multiple. But our module is going to support multiple. So what I'm going to do is actually create a new file, package reverse proxy, and I'm just going to call this upstreams.go. And what we want to do is implement this method. So we want to have a type that implements this method. Serve lookups, serve upstreams, I guess. Struct. There will probably be some fields here so that you can configure this in JSON, of course. Hey, AJ, thanks for joining in. I'm a little intimidated. AJ is kind of a veteran coding, live coding streamer, and also a local here, and I get intimidated when people who know what they're doing watch my live stream. But let's go ahead and make this a Caddy module. So to do that, Caddy modules all have something in common. They have to register themselves with Caddy when the package is loaded. This does not work because it does not implement the Caddy module interface. And that interface is simply, we'll borrow from our reverse proxy here. Let me increase the text size for you. This is huge on my 4K monitor. I hope that it's fine on your little laptop screen now. So SRV upstreams needs to implement this method called Caddy module. And ta-da! Go please is like the best invention since sliced bread, seriously. Except the namespace for the module is http://reverseproxy.upstreams. And we'll call it SRV. So this is the name of our module, or the ID of our module within Caddy. Cool, so now we have a Caddy module that registers itself. The problem is, if we add an interface guard, you can see these are handy compile time checks to make sure that your code implements an interface. I don't think we'll need that one. We definitely do want to implement the upstream source interface. And as you can see, we do not currently implement that, so we get compile errors. Perfect. So we need to add a method. I guess su, SRV upstreams, and oh, bad bug, SRV upstreams. There we go. When copying and pasting code, you always got to go back as if you wrote it yourself. I think it's get upstreams, and we get the HTTP request as input, and we return a list of upstreams to use, and an error maybe. So return nil nil. Ta-da! We're not a provisioner. We probably will be. I'm going to do that later. You'll see, I think, why we need to do that. Okay, so get upstreams. So this is going to work by doing an SRV lookup. So pretty similar, actually, to what this is doing, where we call lookup SRV. But we're going to be a little more like integrated with that. So, I mean, here's the most basic implementation. I mean, it's So this is this code that we have right now is using the default resolver, which this is kind of interesting. I mean, this could be configured, and we can expose that later if we want to, but I don't think we need to right now. So look up SRV, and we're going to have, what is this, like, it's like proto, service and proto, I think. And yeah, service and proto. So we need to give some inputs here, and these can actually come from our config. So if you're writing JSON config, which of course is Caddy's native format, we would have the service, which is a string. We'd have the proto, which is also a string. And then we have the name, which is also a string. Now this, the way that the Go function works, look up SRV, is it will use this given service protocol and name or domain name. Proto is TCP or UDP. Return records are sorted by, so it does all the priority and weight stuff for us. That's great. It constructs a DNS name to look up following the RFC. So to accommodate services publishing SRV records under non-standard names, if both service and proto are empty strings, look up SRV returns or looks up name directly. So that's kind of nifty. We can basically expose this to the user by letting them fill in the service and proto or the name or all three. Or yeah, I guess they would need to fill out either all three or just the name. Anyway, we can add that to our Go documentation. So be like su.service, su.proto, and su.name. Now, tricky thing is we want to support placeholders, so you can use like variables and stuff, kind of like we do here, where if you want to use a placeholder to kind of make your backend maybe dynamic or maybe get it from an environment variable. So we need to get the replacer from the request. This is a pretty standard thing in Caddy. And then we need to do some replacements. And that looks like, I mean, it looks like this, just replace all. So I'm copying a lot of code here, but I'm gonna make it more novel here in a minute. Su dot, we'll start with service. And we'll do this for proto and name. Now things are going to get interesting here in a minute, so stay tuned. Service, proto, name. Cool, so now you can get these values from environment variables or something, and it returns, what, a CNAME, I think, and then the records and an error. If error is not nil, we can probably be smarter about the error handling, make it structured or something. We can do that all later. So, cool, now we have all of the records. So each service that's returned, oh, hey, Francis, thanks for joining the stream. So each service that's returned, we can turn it into an upstream. So let's see here. Upstreams, we can pre-allocate because we know how many we're going to have. Records, upstreams I equals upstream. So an upstream has a host, which we need to get from the host pool. We'll come back to this. Dial is probably the most important thing. Oops. So the dial address, well, they're both important, but this is the most immediately relevant thing. So the record comes back with, so target and port, I think, is what we need to use. Oops. Priority and weight are handled for us. I don't actually know if we're going to need that because we already are sorting by priority and weight thanks to the Go standard library. And so I think it's basically you just join, it's like net.join host port, and it's like record.target record.port. Something like that. Expected operand. Oh, why is there a comma? Yeah. Record.port, oh, it's a uint16. That's fun. So string converse.a. And then this would be an int. Oh, that's great. Love that. Let me just check some notes here. Okay, so that's lovely. Maybe I'll split this out. Okay, so there's part of the upstream. Now before the stream, I went ahead and I knew that we would need to reuse some code here from the reverse proxies provision, where so the host is basically a value that represents the remote host, but this is a globally like deduplicated thing. And so we have a host pool that we share things with. And so it's this little Caddy type. This is a normal convention in Caddy where you need to like reuse values over different config loads and such. So basically calling set host, what it will do is it will stringify the upstream, which is its dial address, which we have just set, because each host is unique by its dial address. And so we basically load or store that. So if it exists, we return it. Otherwise, we create one and we set it on the upstream. So that finishes provisioning the upstream. It's a little weird. But I don't know, it seems to work. And let's see here. Okay, so that's the basic implementation. Then we can just return upstreams. Cool. Okay, couple problems with this though. This is not a fast function. This means that for every request, and not even every request, but every, where are we at here? Every retry, we're going to be querying or doing an SRV lookup. Well, that's no good because that's not very efficient or necessary. In fact, the client wants, that's requesting this work, would like an interval that they can specify as to how often to refresh. There's a couple ways to do this. One is to have a go routine in the background that, oh, and I saw some comments come in. 1 second. One is to have a go routine in the background that is just updating, like running on a ticker, basically. Another is to do it kind of lazily. So basically when get upstreams is called, we check to see the last time that we updated the SRV lookup. And if it was too long ago, then we do it really quick and then we return the list. So like once in a while, get upstreams will be a little slower, but only once per interval. So that's, I think, acceptable. So that could be configured. Okay, so questions in the chat. What was the record.port type? It was a uint16. Yeah, it's a uint16, and the string convert I to A function takes an int, and so we just have to convert that, and join host port takes strings, so great. Size is great. Style question, why new? Oh, in set host. Because it looks pretty. I think it looks prettier than this mess. It also makes it more clear to me that new like is allocating and like make it like on the heap. I don't know. Yes, that's obvious too from the ampersand, but it's just a style preference. Okay, so we have this interval and we only want to, this is where we introduce caching, so we're going to introduce bugs. I think what we're going to need now, the nice thing about this lookup is they're global. We don't need to scope these because no matter what the config, what part of the config, a lookup to this with this input is going to give us the same like results. And so we're going to need a map to store these lookups. And kind of thinking, just look at my notes here. Yeah, so we'll probably want to make a something like where we store lookup. And the reason, so I mean, we could just store the lookup directly, but I want to make a new type. Because, yes, we want to store the upstreams. Sorry, so this is the configuration. We need to store that because we need to check for freshness. And then we'll also, of course, want to store the actual like results from the lookup. AJ says, I like to do a fresh, no update versus stale, update but don't wait, versus expired, stop the world and update. Oh, yeah. That's fine too. Yeah, we'll do something kind of similar actually. In fact, we'll probably need to know whether this is fresh or not, and we can use it right away if the time that has passed since yeah, is less than the interval. Man, Go Please is so cool. Look at that autocomplete. Oh, this is going to be concurrent. So I do this a lot. So we'll need to lock and synchronize this. Okay, that's going to be fun. So let's go back up here. And you'll notice I made, actually, this should probably be a read-write mutex because we want to allow lots of readers. Okay, let's pretend that the cache is magically working. And so what needs to happen, honestly, is all we need to do, like the fast path that most requests will be satisfied by would be just a cache hit. So see if we can find it. Should probably serialize this somehow. And I think if I remember correctly, this format looks, well, let's see here. Lookup serve. This is the format. We can probably just do this, right? This should uniquely identify the SRV input. I believe, did I get that right? Service proto name. Yeah, service proto name. Okay. And so we can use that as a key here. Make sure to unlock our critical portion there. So the fast path, this is the fast path right here. And most requests will hit this and our return will be immediate and happy day. Cache miss, or if it's not fresh enough, then okay, we need to do a SRV lookup. So this is a little tricky because if we want to do the concurrency right, we have to assume that two get upstreams are being called at the same time. And maybe both of them notice the cache miss because notice that the read lock is very short, and that's good. We want it to be efficient and fast. But if we are, sorry, I'm distracted by things on my screen. Okay, yeah. Just looking at, I had some stream troubles earlier, and it looks like things are working better now. Anyway, so both of them might obtain and release this lock at this kind of at the same time. Obviously not at, well, yeah, at the same time because it's a read lock. And then if both of them notice it's a miss or not fresh, then we don't want them to both do the update. And so in order to fix that, we actually need to obtain another lock. And this will be a write lock. So only one of them will obtain this lock at the same time, but one of them will obtain this first. And so we need to find out if maybe it has already been updated. So the one that obtained it first will do the update, but the second one will come in and get the lock thinking it needs to do the update. And so we need to actually check and see, oh, does it still need to be updated? And if not, then great, just return. So yeah, we don't want to duplicate our work. And actually, we can just reuse this. This is a very minor optimization, very, very minor. Cool, so now by the time we get here, right here, we know that we are the only one to be doing this update. Oh, Francis asked if we need to check OK here on this map lookup. We can, but the return value is not a pointer, so it's always going to have a value. And fresh will always return false if these are empty values, because we are not anywhere near 1970, and the interval is surely less than 40 years, 50 years now? Anyway, so yeah, I think we are okay there, but that's always a good thing to check for. So now we know we need to do the work, and that, I mean, we've already implemented that code. The tricky thing is now we need to store we need to cache the results. So do the work, get the updated records, cache the results. So we already have our write lock. That's the key. We have our type here that, a little clumsy today. So store the config so we can determine freshness, as well as current time that we updated this, and the list of results, basically the upstreams. And I think that's it. Oh, actually, we need to expire these. I will probably not get into that on this stream, but yes, our cache could potentially infinitely grow if we don't expire them. So we want to avoid that, obviously. There are a couple ways to do that. One is you set a size limit and then just do random eviction, or we could set a timer that runs in the background and deletes it after a certain amount of time of inactivity, or whatever. Like, we could do all sorts of things. But I don't know, I kind of like random eviction at a certain size because that's really easy. So anyway, let's see here. Don't mind my random scrolling, it's all over the place, I know. Okay, and actually that might do the trick for the basic functionality. I do want to implement a provision method. This is something that Caddy calls when it is loading it's when it's loading the config. This will help it compile because our interface guard asserts that it's a provisioner. I don't know that we need to do much right now. I mean, we could probably check to make sure like the interval is a valid value and maybe set some defaults. I'm not going to do that on this stream because that's kind of boring. Check inputs. And I see another question. Give me a second. Check inputs, set defaults. We'll figure that out. Francis asks, why does it always return a value? Might have missed that, but can it be nil if the entry wasn't ever put in there? Good question. The answer is, I believe, is no. When you index into a map, it will always return the type of the value. Even if it'll return, if it doesn't exist at that key, it will return the empty value for that type. So if it's a pointer type, it will return nil, or if it's an interface type, it'll return nil. But if it's a concrete, like a struct type that's not a pointer, it will return an empty value of that. So I don't believe this can ever be nil. Yeah, because otherwise that would break Go's typing system, because then cached could be nil or a struct type. So yeah, I think this code is safe. And I think we handled concurrency well. Obviously, you have to double check and make sure we didn't step on another Go routine's toes here. Don't want to repeat all this work, which isn't honestly that much work, but anything involving the network, especially DNS, oh man, like, yeah, don't want to mess with that. Cool, so actually, we have another feature request. If you remember, this is from also, like, this is actually Caddy's oldest open issue. It's almost 6 years old now. 5 years old? Almost 5 years old. They want to load balance across multiple A records. They want these to expand to multiple upstreams. Well, we just wrote code that basically does that, but for SRV lookups. So let's do it for A lookups, and this will be another module. So I'm just going to copy and paste everything, and we'll just go to town. I will get rid of these comment barriers here in just a second. I just want to separate things. So type A upstreams, I guess. That's kind of weird, but service and proto name. Okay, so SRV, all the remaining references to SRV upstreams needs to be A upstreams. And I'm gonna rename SU just because that's I'm gonna name it to AU and make sure that's renamed, and obviously the inputs are gonna be different. I think all we need for these is like a name and an interval, of course. And so the string method would probably just be, which we don't even need reflection for that. Okay. Provision, yeah, get upstreams. Okay, just kind of renaming stuff. Obviously, so yeah, all of this is gonna change. Actually, I'm just gonna comment this whole method out. Might borrow from some of it. SRV lookup. I guess that's gonna be an A lookup. And it's going to, yeah, be very similar. And of course, we're not going to have, hang on, oh yeah, we're not going to have SRVs. We're going to have like A records, but also quadruple A for IPv6. So I'm going to call it this, I think. This is kind of weird. But anyway, that's where we'll store. That'll be our cache, I guess. And then just insert that. Okay, great. So this method, I think, is pretty similar. I'm gonna actually just go ahead and uncomment this. We'll tackle it one by one, and then we'll be done for the day. So obviously, we're not going to use SRVs. We are going to use A. It's a lot of A's. Don't judge me. You've always wanted to name a variable this. And then, yeah, it's pretty much the same logic, and maybe I can deduplicate this later and extract some stuff out so we aren't repeating code. Don't have service and proto, and then obviously the DNS lookup changes. I think the method for this is lookup IP, looks up hosts using the local resolver. I think it might be that one. Is that right? And the input is context and thank goodness it takes context, and then a host, so name, I guess. There's only 2 return values, and they are IP addresses. Keys, IP. Oh yeah, so the Upstreams dial address is going to be the IP as a string, and oh yeah, what's the port gonna be? I guess the user will have to configure that. Port. I think we can make this a string because we want the user to be able to set placeholders. There is a type that, like caddy.weakstring, I think, or caddy. I don't remember. I'll have to look it up if we wanted to actually make this an integer, but I think we can just leave it a string because then you can use placeholders, which could be handy. So if your port is, again, like in some sort of environment variable or in any way dynamic, port, ta-da. So that's your dial address. I think most of the rest of the stuff is the same. This is an A lookup. And have A upstreams instead of SRV upstreams. All right, I think that might be it. So yeah, this will return your upstreams based on multiple A or quadruple A records. Because yeah, the Go doc says it supports both IPv4 and IPv6. Cool. And obviously I need to do some input checks there and defaults. But I think this is looking good. We have just written about 200 lines of code that will give us dynamic backends with DNS lookups. And of course, this is just one possibility. These modules can do anything and get their backends any other way. And it happens during retries or like between retries. So that's really handy if the list of upstreams does in fact change while requests are being blocked while we look for an up backend. And in theory, this code will work. I'm not going to go into testing and trying it all right now in this stream, but the Caddy module system, I mean, we already set up the provisioning of this module, we load it and we set it here. And so all we would have to do if we wanted to use this right now is make a little JSON config and just stick in, oh, actually need to register it to SRB. There we go. And then we would just stick in an object that has, you know, a service proto name interval, or for the other one, name and port interval, and it should just start working. So that's all there is to it. In, what is it? Are we at, how long has this been going? Where the heck is the clock? About 40 minutes. So in about 30-40 minutes, we've implemented 2 Caddy modules that extend its reverse proxy functionality. And I think that's all we need to do for today. So if you enjoyed this, please tune in next time, share this around. Get your company to sponsor Caddy. We honestly need the sponsorships, and this is really cool functionality that other web servers, it's especially the traditional ones, it's really hard to find these kinds of features. But yeah, if you find Caddy useful, please sponsor it. You can do that on GitHub. And let's see here. Oh, Francis says, I think we want to have static upstreams in here as a backwards compat layer for old upstreams. Oh yeah, so Francis is talking about, we have 2 config fields here to specify upstreams. We have the static one with the old one, and we have the new one, dynamic upstreams. And it would be nice if there was only one way to specify the upstreams. I think I agree, that would be nice. I hate adding new stuff that would deprecate old stuff, because it's I wish I just thought of that in the first place. We can revisit this before we finish, but yeah, that's definitely something to consider. So, oh, thanks AJ. Yeah, I found it. It's just, actually, I don't see the timer. Oh yeah, no, I do. Okay, well, thanks. Anyways, so that's all for today. But again, feel free to sponsor Caddy and help out in the forums. We could use you in our community. So until next time.